This video is for Chapter 3 in Chemistry, and it's going to be on mole conversions. You can find more information in your book on pages 82 to 87 on this if you're looking for more examples. Now, you've learned the following facts about a mole. You know that a mole is a counting number, and it can represent a few different things. One is that it is 6.02 times 10 to the 23rd atoms, ions, formula units, or molecules. You also know that 1 mole is the same as the molar mass of any element or compound in grams, and you can find that on your periodic table. And then the last thing that you've learned is that 1 mole is equal to 22.4 liters of any gas at STP, standard temperature and pressure. Now, what we're going to do is the mole is kind of like a base unit, and we can convert from moles to grams or grams to moles. We can convert from moles to liters of a gas, or from liters of a gas back to moles. Or we could convert from moles to particles, or from particles back to moles. So we're going to practice some of these problems here. Now this first problem is converting 45.7 grams of water to moles. So using your little diagram that we had on your sheet for you, this is where we're starting, grams, and I want to get to moles. Now you notice you can do that in one step. You are going to do this just like you've done any conversion problem you've done in previous chapters. You always start by writing down the given, 45.7 grams of H2O. And now you're going to multiply by a conversion factor. For some of you, putting this over 1 will be really helpful. Now the label you want to get rid of is grams of H2O. And the label you want to keep or turn it into is moles of H2O. Now, if you look at your diagram, the way we get the information we need from grams to moles is by looking at our periodic table. The 1 will always go by the mole. Now, we're going to look up water. Water has 2 H's. Okay, each H is 1.01 grams, and we'd have to multiply by 2. Oxygen, we only have 1 of them. It weighs 16.00 grams. When we add these together, the total mass of a water molecule is going to be 18.02. So we're going to put that number on the bottom of our conversion. And since grams of water now cancel, our answer would be in moles. And if you use your calculator to check this, you should get an answer of 2.54 moles of H2O. That has the right number of significant digits. Now, in the next practice problems that I'm going to do in the video, if you want to try them on your own, pause the video and give them a try, and then you can always turn the video back on to see if you're doing them correctly and correct any mistakes you might happen to make. So, problem number 2, I'm asking you to start with 8.73 moles of CO2 and convert that to molecules. So here I'm starting with moles, and now I want to go to molecules. It's still a one-step problem. So I'm going to write 8.73 moles of CO2. That's my given. I'm going to put that over 1. And I can do this in one step. Moles of CO2 will be going down on the bottom of the fraction. Molecules of CO2 will go up at the top. And there is no abbreviation for molecules. You have to write out the whole word. Now, 1 always goes by the mole. And if you look at this on your sheet, the number 6.02 times 10 to the 23rd is always the number we're going to use when we convert from moles to particles. And if you do the math in your calculator, make sure you remember how to correctly enter scientific notation. You should get an answer of 5.26 times 10 to the 24th molecules of CO2. Okay. Our next problem is going to ask you or give you liters of oxygen. That's what we're starting with, 4.923 liters of O2, and it's asking you to convert it to moles. So we're starting over here now, liters, and converting over here to moles. Again, just one step. Now, you always start by writing down the given information, 4.923 liters of O2. You're going to put that over 1. And the label now that you want on the bottom is liters of O2, and we want to change that to moles of O2. Now looking at your chart, 1 always goes by the mole, and the number that we always use for liters, assuming it's at STP, is 22.4. So you're going to take 4.923 and divide by 22.4. Now your answer can have 4 significant digits. So you're going to have 0.2198 moles of O2. Okay. And we're going to do one last practice problem because I want you to see what it would be like to do one that needs more than one step. If you look at the given in this problem, 0.95 grams of sodium, so I'm starting here, and I want to convert that to atoms, which means I want to get down here. But these two boxes are not connected themselves. You have to go to moles first and then particles. So my path will be to go to grams, from grams to moles, and then from moles to atoms. I'm going to start by writing down what I was given, 0.95 grams of sodium. And I'm going to put that over 1. Now I would like the label grams of Na on the bottom and moles of Na to be on the top. The 1 always goes by the mole. And if you look at your chart, when you're going from grams to moles, you always look this up on the periodic table. So if you look up on the periodic table, Na has a mass of 22.99 grams. Now, your grams would cancel, but we're not at atoms yet. So we want to keep going. We want to get rid of moles. We put that down here. And we want to change it to atoms of Na. Now, the number 1 always goes by mole, and when we're going from moles to atoms, the step, or the number we always use is 6.02 times 10 to the 23rd. So now you're ready. Looking at your labels, moles will cancel. Our answer would be in atoms. You just need to enter this into the calculator, being really careful that you enter your scientific notation properly and do your math correctly, and you should get an answer with 2 significant digits as 2.5 times 10 to the 22nd atoms of Na. So that was a quick video on how to do mole conversions. You should now go ahead and do the practice problem, and that will be your learning check. Good luck.